Hi everyone. So today we will see the topic files in C. It's a very important topic from an exam perspective as well as from an application point of view. It is a very important topic and it's a very simple topic. Be with me for 20 minutes and you will also agree that it's a simple topic. Okay. So before going on to the subject, we will see what's the need of a file. So everyone have seen files and everyone have used files. So let it be in your mobile phones or let it be in your laptop, there will be a lot of files. Say like you will be having documents, you will be having images, you may be having audio files, you may be having video files. So all these are files which are stored in your memory. So what is the need for that? Okay, think of an audio file. You are browsing through a say music app, you have heard a song, so you have streamed it and you have heard that song, you like that song. Okay. So whenever you want to hear it again, you can go to that app and you can stream it. Okay. Or another way is that you can download that song so that it will be in your mobile phone or it will be in your memory, so that whenever you need it without any streaming, you can hear that song. So what option you will take? Of course you are going to download, right? Because that will be in your memory. So regardless of whether you are using net or not, you can hear that song whenever you need it. So to generalize, suppose if you need some data to refer again and again, you can store that in a file. In our case also, we are using files for storing purpose. So you may have done program to sort a list of numbers or arrange a list of student names according to their alphabet or according to their rank. So in all those cases, this result will be required for a further reference. In that case, we will be actually storing it into a file. And similarly, suppose if you are considering a college with say 500 students, you are going to store all the data of those students and you are going to display it according to some register number. Okay. So in that case, there is no person going to enter the details of 500 students after executing the code. The code will be executing, it will be taking data from a file. The details of student will be saved in some file. So from that file, they will be fetching the data. It will be doing the manipulation process, they will be finding out the result, and that result will be written back to the file. So that whenever we require that data, we will be accessing the file. We may not be executing the code again and again. That will be a one-time process. Okay. So coming to what we have learned in C, now you know how to store a data. You can use any primitive data types or you can go for data structures like arrays and structures. For any manipulation, you can use operators on these data. Along with operators and control statements, you can do whatever necessary and you will get the required output. So now what we are going to do is, we have to store this our required output. We will be getting an output. That output should be stored into a file. Okay. So that means we have to store this data into a file, and this process is called as writing. Okay. Similarly, so far what we have seen is that through a keyboard, user will be entering the data, required input, and that data will be stored in some data structures and you will be processing that data. In most of the real-time applications, it will not be the user that will be fetching the data, it will be fetched from some file. So the next thing is that the input will be fetched from data, and that process is called as reading of data. So the data will be read from the file and then we will be doing the operation and the result obtained will be written back into the file. Okay. And even if we say file operation, the basic operations we are going to do in a file is reading and writing. Because here you can see we are reading the data and we are going to store it into some known format, into arrays or structures or some primitive data type. So the data inside the file is put into a known data type, and already we know how to operate with this data. We will operate it, we will get the desired output. Instead of displaying it in the console or in a prompt, we will write it back to the file. So this is what the entire process of file does. Okay. So C also provides this option of reading and writing into file. We can create a file, we can open it, we can close it. There are various other operations which will be supported by C language. So next we will see the different file handling functions. So continuing with files in C, first of all, the file can be accessed only through a pointer, which will be called as a file pointer. And first we will see how we can create a file pointer in C language. So it will be written like file, which is the type, star, and you can give any variable name. So this is how you will be creating a file pointer, a pointer variable of type file. This is a inbuilt structure which is included in stdio.h file. So here you are having the definition for file. So it will be storing the size of the file, it will be storing the names, the status, etc. So those data will be already in here. So we are actually creating an object for that particular structure. Okay, and using this file pointer you can do all the operations. So we will see the different operations. Suppose if you have to create a file, we can use fopen. For reading and writing all or opening a file, we have to use the function fopen. So that is one for opening, and for closing you can use fclose. And the major two other operations are read and write. And for reading and writing you are having various options. Suppose for reading you are having fgetc to read character one by one from the file, fscanf, fgets, and fread are available. Similarly for writing you are having fputc, fprintf, fputs, and fwrite. And for closing you are having fclose. We have already told that. Okay, so we will see these functions one by one. Okay, now we will continue with different file handling functions. We are going to start with fopen. So before that we can see files can be classified as two. One is text files and another one is binary files. Okay, here we will be dealing only with text files, but we will see what is a binary file as well. Okay, as the name suggests, if it is a binary file, the data is going to be get stored in the form of zeros and ones. And in the case of text files, each character will be stored in memory with their ASCII value. Okay, so that is the difference. So if you are using a file for say storing images, or if you are going to store with MP3 format, all those will be binary files. Suppose if you are having an MP3 format file, and if you try to right click it and open with say Word or something, you will be getting some data which is not human readable. Okay, that is a binary format file. Whereas in the case of text, each character will be saved with its respective ASCII code. Okay, so we are going to deal with text files, and we will also see how we can create a binary file. Okay, but we will be operating on text files. So first we will see the fopen function. This having two parameters. One is the name of the file, and another one is the mode by which we are going to open the file. So first see what are the different modes. The main ones are, one is read mode. So if you are opening a file in read mode, we are telling the compiler that our purpose is to read contents from the file. Similarly you are having W, which is denoting write operation, and A for append operation. Okay, so these are the basic three modes, and we are having some other, we will see it in a short while. Okay, so I will show you an example as well. So I have created a file pointer using the file type, so file star fp. Now I am saying fp is equal to fopen file1 in write mode. So file1 will be the name of that file. Now what the compiler does is that it will check for a file named as file1 in the current directory. Okay, suppose if that file is present, it will return the starting address of that, which means a pointer to that file will be returned, and that address will be now in fp. So for making it more clear, you can assume it like this. So you are having a file named as file1. So the compiler finds that thing, and the starting address will be given to this fp. So using fp you can access the contents in the file. Okay, and suppose if this file is not present in memory, okay, consider that in the current directory file1 is not present. In such a case, it will create a file with the name file1. Okay, and we are going to write contents into it. Okay, so that is the operation of a write mode. Suppose if file is open, it will open that file. Suppose if that file is not present, it will create that file. And one more thing to add, you assume that there is a file already existing and it is having some data. And now if you open it with write mode and if you try to write something into the file, actually the all data will be gone. Okay, it will be overwriting the content. Okay, the process is called as truncation. It will do a file truncate, which means the file structure will be remaining, but the contents inside the file will be deleted. Okay, so that is a problem with a write mode. Suppose if you are having or opening an existing file and if you try to write, the already existing content will be lost. Okay, and now another mode is read mode. The purpose is to read from the data, read from the file. If the file 1 is existing, it will return the pointer, and if that file is not existing, it will return a null. So, okay, so it is not going to create a file. If the file is not present, it will return a null. And now the third mode is append mode. If you are going to open it in append mode, if that file is not existing, a file will be created. If a file is already existing, that file will be opened, and there will be a pointer at the beginning which is used to read the contents, and there will be a pointer at the end of the file, so that suppose if you are writing something else into that file, that will be added on to the previous content. Okay, so the previous content will not be lost. Instead, it will append the new data beneath the original data. So that is called as append mode. Now similarly, there are some modification with R plus, W plus and A plus. So this is opening a file in read mode, but it is also with this you can also do a write operation. So reading and writing is possible. Here also, if the file is present, it will return the pointer. If the file is not present, it will return a null. In the case of W plus, again we are opening the file for reading as well as writing. If the file is not existing, a new file will be created. If there is file is already existing, it will truncate the file. Okay, and A plus, which is append plus, here also we can do read as well as write operation. If the file is not present, it is going to create a new file, and if there is already content, it is going to append data. Okay. Now I have told about binary files. So once we are doing simply fopen file1 and we are writing the mode, it will be creating text files. And suppose if you are interested in creating a binary file, you will be writing fopen, the file name, and in the mode, if you write RB, it means that you are going to read from a binary file. Similarly, if you have to create a binary file, you will say fopen, the new file name, and the mode will be WB, which means a binary format file will be created. Similarly, you are having AB, R plus B, W plus B, and A plus B. So these are the different modes by which we can open a file, and these will be the different formats we will be using in general. In most of the cases, we will be dealing with these things. Okay. So I hope you got the idea about fopen function. It will be having two parameters, file name and mode. Okay. Suppose our aim is to create a new file, we will be writing file name followed by write mode. So if the file is not existing, it will create a new file, and the file handle or file pointer will be returned to this variable. Okay. You can use any variable name. So for simplicity, I have used it as FP, denoting file pointer. And to write content or to read content or even to close the file, we will be making use of this file pointer. Okay. So now we will move on to the second functionality, which is fclose, the most simple function. The purpose is also clear. We are going to close the file. We have done with the file. Now we are going to close the file. So while closing, what happens is that any memory which is allocated during the fopen function will be deallocated. Okay, fine. Now it is also having one parameter. Think of a scenario where you are having multiple files open. Okay, you have file 1 as well as file n, which is in open status. FP is pointing to file 1 and FP2 is pointing to file n. My aim is to close file 1. Okay, so how can I make the compiler understand? I will say fclose followed by the file pointer. So if I say I have done the operation, and if we say fclose of FP. I'll denote the file pointer as well. So the system will understand that it is meant to close the file 1. Okay, so this is all about fclose and it is a better practice to always use this fclose function in the program itself. Whenever we have done with the file operation, you have to do fclose. Suppose if we are not doing it, the system will automatically close it. When the program terminates, it will automatically close the file and it will deallocate the memory. But suppose if we are not coming out of the program in the normal manner, say due to some segmentation fault or due to some runtime error, if we are coming out of the program, it will not be done. Okay, now it will be the headache of operating system. So it is always a better practice to write the fclose statement inside the program itself. Okay.